Welcome to this explainer. I want to kick things off right away with a brilliant thought from computer pioneer Alan Kay. He said computers are to computing as instruments are to music. Software is the score whose interpretations amplifies our reach and lifts our spirits, the shaping of the invisible. It's so true, right? When we're writing code, we aren't just handing a machine a boring list of chores. We are literally shaping invisible structures of data to solve complex real-world problems.
So let's dive straight into Chapter 10 and start shaping that invisible world. Today, we're going to master two absolutely foundational data structures in Python, tuples and dictionaries. These two structures are the heavy lifters. They fundamentally dictate exactly how we store, secure, and retrieve our data. Honestly, mastering these is the real dividing line between someone who just writes basic scripts and someone who truly architects data.
We're going to tackle this in 5 straightforward steps. First, 2 paradigms for data. Second, tuples, the secure vault. Third, dictionaries, the switchboard. Fourth, the synthesis of keys. And finally, number 5, applied mastery and diagnostics.
Okay, zooming out for a second. Section 1, 2 paradigms for data. Before we get into the syntax, we have to understand the fundamental difference in how data can even be organized. Think of it like this. We have sequences and we have mappings. A sequence is basically an ordered vault. Your data is perfectly lined up, and you retrieve it by its physical numeric location, index 0, index 1, index 2, and so on. Mappings, on the other hand, are like a dynamic switchboard. The physical order, it doesn't matter at all. Instead, data is retrieved by custom, unique keys. These two opposing concepts form the absolute bedrock of how Python handles data.
Let's crack open that first paradigm. Section 2, tuples, the secure vault.
Tuples group your data together using parentheses, which is great because you can store numbers, strings, or even a crazy mix of data types. But, and pay attention here because this catches everyone, there is a crucial single-element rule. If you want to create a tuple with just one single item in it, say the number 20, you absolutely must include a trailing comma. If you just wrap the number 20 in parentheses, Python's going to completely ignore them and treat it as a standard integer. That one tiny comma tells Python, hey, build a sequence here. Trust me, forgetting it is a programmer's rite of passage that will easily cost you 3 hours of totally avoidable debugging.
Now, what really makes a tuple is immutability. And immutability is just a fancy way of saying it is rigidly unchangeable and securely locked down the moment it's created. Once you forge a tuple, that's it. Its structure is set in stone. This is basically a permanent, built-in security measure for your most important data.
So what happens if you try to mess with it? Say you try to reassign a value inside that locked sequence, like changing the item at index 4 to the number 10. Well, bam, Python throws up the immutability shield. You'll instantly get a type error loudly declaring that a tuple object does not support item assignment. Your constants stay protected. Now, there is one wild little exception to this rule. If you somehow hide a mutable structure like a list completely inside your tuple, the list itself can still be modified. Its structural position in the tuple is locked, but its contents aren't. Kinda sneaky, right?
But don't worry, just because the vault is locked doesn't mean your data is trapped. You can cleanly extract exactly what you need using standard slicing. You can pull a standard slice to grab just a middle chunk. You can use step slicing with a third parameter to skip over items, or you can even use a negative step to read the entire data sequence completely backward. And through all of this, the original tuple remains perfectly untouched.
On top of that, Python gives you an entire dashboard of built-in analytical tools. Rather than trying to change the original tuple, you can generate totally new ones using concatenation with a simple plus sign, or use an asterisk to repeat the data. Need to interrogate the data fast? You can check membership, count frequencies, or instantly pull the absolute minimum and maximum elements in a flash.
Let me show you an incredibly practical superpower this unlocks. Have you ever needed to swap the values of 2 variables? In older programming languages, you'd have to create this clumsy third variable just to hold the data so you don't accidentally overwrite it during the swap. Well, tuple unpacking lets you do this with ridiculous elegance. You just type num1, num2 equals num2, num1. Boom. One perfectly clean line of code, and Python handles the entire swap seamlessly behind the scenes.
And this unpacking trick is an absolute game changer for writing functions. Because tuples are perfectly immutable and hold multiple values at once, they are the ideal vehicle for a function that needs to output more than one result. Let's say you write a function to process a circle. It can calculate the area, calculate the circumference, package them both into one highly secure tuple, and pass it across your program to be instantly unpacked by the receiver. It's incredibly clean.
All right, let's shift gears, speed things up a bit,
and dive into our second architectural paradigm. Section 3, Dictionaries, the switchboard.
Dictionaries are a totally different beast from sequences. They are non-scalar mappings built using curly braces. With these, physical sequential order literally doesn't matter. Instead, dictionaries work by mapping a unique key directly to a value. Finding a value is practically instantaneous, even if the dictionary is utterly massive, just as long as you know the key. It's an incredibly intelligent, hyper-optimized switchboard for your data.
Which brings us to a really fascinating climax, where these two seemingly opposite data structures actually collide. Section 4, the synthesis of keys. So how do these structures work together? Well, it all comes down to the rule of keys. Because a dictionary acts as a switchboard, its keys must be 100% unique and structurally immutable. Think about it. If a key could just change its own structure, the computer would completely lose track of where the connected value is stored. So here is the synthesis. You can actually use those rigid, immutable tuples we just talked about as highly complex dictionary keys. Imagine using a tuple of GPS coordinates as a key to map a location. But if you ever try to use a shifting, mutable list as a key, Python will immediately crash the party and throw an error. Now, while the keys themselves must be stubbornly rigid, the dictionary structure overall is incredibly flexible. This is dynamic mutability in action. Unlike the locked vault of a tuple, you can instantly overwrite an existing dictionary value just by referencing its key. Or you can expand your switchboard by declaring a brand new key value connection on the fly. There's absolutely no immutability shield stopping you from updating the payloads or expanding the map as your program runs. Okay, we've got the locked vault, and we've got the dynamic switchboard. Let's wrap this up with Section 5, Applied Mastery and Diagnostics. How do we actually know which tool to reach for in the real world? Well, dictionaries happen to be the mathematically perfect structure for some very common tasks. Take a character counter, for example. If it's reading a string like Hello World, it uses a dictionary to dynamically create keys for every new letter it sees, and it just increments the value for letters it already knows. You get a perfect frequency tally in milliseconds. Or think about a translation engine. It uses a dictionary as its core routing system, taking a user input like the number 6 and instantly mapping it to the word 6. To lock all of this in, here is your ultimate data diagnostic matrix. When you're architecting a program, you really just have to look at your data needs. Do you need a dynamic collection of data that's going to constantly change size and shape? Go with lists. Do you need secure, rigid records that must never be altered? You want tuples. Do you need a rapid, unordered mapping system for building databases, translation engines, or tallying frequencies? Reach for dictionaries. So, the big core takeaways from today's explainer. Tuples protect your constants with locked sequences, and whatever you do, please don't forget that trailing comma for single elements. Dictionaries build rapid, non-scalar relationships, but they entirely rely on those immutable keys to function. And finally, never forget the sheer elegance of tuple unpacking. It's literally a Python superpower for cleanly swapping variables and handling multiple function outputs. Great programmers do so much more than just type out a list of instructions. They shape the invisible. They do this by choosing the exact right structural tools for the job. They protect their constants, and they intelligently connect their relationships. You now know the deep mechanics behind how tuples and dictionaries work. So the only question left to ask is, how are you going to build your next data architecture? Thanks for joining me on this explainer, and happy coding!